Hello and welcome back to KXAM Plus. Thanks so much for joining us here, whether you're watching on a streaming app, on your television, or live on social medias. Thanks for being here with us. We have our Kristen's Classroom segment that we do every Wednesday morning with KXAN meteorologist Kristen Curry. Kristen, thanks for joining me.
Of course, happy to be here.
How are you doing this morning?
Pretty good. It's been relatively quiet weather-wise, ready for something exciting to happen. And it hasn't happened yet, but we need a little bit of rain and some cooler weather, hoping things change soon.
Yeah, that's what I was going to say. We're missing that rain. Hopefully it comes soon.
Yeah, absolutely. Got a small chance this weekend, but in general, sunshine is going to be dominating these skies for the next several days. So if we can't get the rain, we might as well get some nice outside weather. In the mornings and the evenings have been feeling really good.
Yes, they have. And I'm excited to jump into that fall weather. I know we started a little later here in Central Texas, but we're waiting for it.
Eventually, sooner rather than later, I think, as we get a little further into the month.
Well, today we're talking about types of air masses, but before we jump into it, can we kind of discuss what is a type of air mass?
Yes, absolutely. This is something kind of like the basics of meteorology that I wanted to talk about because it is the science of why our temperatures are the way they are and why we expect temperature trends to change moving forward. So I know this is a very busy map, but I'm going to break it down for you. When we talk about air masses, you basically think of it, speaking to the kids, it's a blob of air. That blob of air has got to come from somewhere, and it originates in different spots on our planet. When it comes to North America, the United States, we're looking at a few different types of air masses, a few different types of those blobs of air. We separate them first by continental versus maritime. So this is whether they form initially over land or if they form initially over water. And that kind of plays into how much moisture that blob of air has. So if you look at the very small lowercase letter at the very top of the blobs here, it's either a small m or a small c. Yep. So small m would be maritime. So think ocean. Small c would be for continental. So think land. As far as that second letter goes, it kind of plays into where it originates and the type of air you would think, the temperature of the air, that it would be in that area. So for example, the easiest one is the CA, continental Arctic. That uppercase A stands for Arctic. That means it's an air mass that started over land up in the Arctic. And those are typically the coldest air masses because warmer air holds more water. So we typically see milder temperatures, relatively speaking, over water than we do land. But those CA air masses, those continental land, Arctic air masses that come down from the North Pole are cold blobs of air that can come down and oftentimes reach, Canada, northern plains, but can even sometimes move all the way down here in Central Texas.
Oh, and which ones specifically affect us more often here in Central
we
Texas?
kind of are all over the place. I will say the CA air masses, the continental Arctics, are harder to get because we live so far south here in Texas, but we certainly have had that kind of air over our area. The CP, the continental polar. So Arctic is as cold as it gets.
Yeah.
Polar is right underneath that. So cold, but not as cold. Those continental polar air masses come in and they can certainly drop our temperatures too. You'll notice the little blobs on the side, those air blobs, MP, M being ocean, maritime, ocean, P. So over the ocean, but polar, so not quite as cold as Arctic. We can get some of those. And then the MP on the other side too is oftentimes what we can get in the Northeast that can really build up to some snow. As I mentioned, warmer air holds more water. So it's not quite as cold, but cold, and you've got a lot more moisture to play with. You can get some big time snows there in the Northeast and up in the northern Appalachians. On the southern side, you'll notice the CT and the MTs. Those are oftentimes what we get here in Texas. CT.
The red ones.
Yep, the red ones indicating warmer air blobs or warmer air masses. CT being continental, land, tropical. So when you hear tropical, you think of humid, right?
Yes.
So or warm, and that's exactly what we're talking about here. Maybe not quite as humid because it started overland. Maybe this air blob originated over Mexico, right? The deserts of Mexico. Those MT masses, M starting over the ocean, T being warm, those are the warm, humid blobs of air that can oftentimes settle on top of Texas, or really the southern states in general. So when we're talking about the very basics of meteorology, the blobs of air that move in and around our country, brought in by the jet stream, brought in by the cold fronts, warm fronts, whatever it might be, these are those blobs of air that we're talking about. So just to kind of recap the air mass side of it, CA, continental, Arctic. C for continent, Arctic being very, very cold, the coldest it gets. CP being sea continental land, P being cold, but not quite as cold as Arctic. CT, that's continental tropical, I should say, and that's over land, but warmer. You oftentimes get those, honestly, over the deserts. Continental being over land, but tropical being warm. Maritime polar, maritime tropical. So that would just be the M over the ocean. Polar,
not as cold.
Yep.
Yeah.
And then tropical being warm, the warm, sticky kind of stuff there. So that's kind of the recap of air masses that most affect us here in the United States, whether they form over land or form over water. And then what is the of that area that they're forming over,
and that it brings to us, right?
For sure. And then they move around with weather, right? Weather is caused by the uneven heating of the sun. So we get a lot more sun, a lot more warmth at the tropics, at the equator, and very little of that at the poles. And so our Earth is constantly trying to balance itself out, bring some of that warmer temperatures from the more sunshine at the tropics up to the poles where they don't have as many. And that moves around with the jet stream and oftentimes the cold front. So we checked off the list, air mattress.
Air mattress. I think you're sleepy.
Yeah, I know. Maybe I should get some water. I will tell you, sometimes that 2 a.m. alarm clock can really get you on a Wednesday.
I do not blame you. I would not be happy if I woke up at 2 a.m.
Air mattress, air maxes. Y'all know what I mean, right?
Yes.
So now that we know what air masses are in the different types, let's roll into the fronts, because this, I think, is a little bit more tangible for a lot of us. You see these on the weather maps we show on TV.
We're talking about them more and more.
For sure.
Yeah.
For sure. We've got one coming this weekend, right? There are different types of cold fronts, and it plays into what we just talked about with the air masses. Fronts are basically just boundaries between those air masses. So the Pacific cold front is exactly what you would think. It's a cold front that brings in an air blob, an air mass from the Pacific. Now, these oftentimes are what we get here in Central Texas. We see this all the time. The one we've got this weekend coming in off the Pacific, cooler, but not necessarily cold. And what's often important too, especially here in Texas, when we're in the middle of the nation, this air blob starts over the Pacific, and it has to move over pretty much half the U.S., half the western side of the U.S. So that air is moving over land in Oregon, Nevada, Colorado, Utah, Arizona, New Mexico before that air blob finally makes it to Texas. As it does so, that air blob will modify some. I mean, it'll lose a little heat here, probably, or lose a little bit, gain heat, lose some of its coolness as you get into the desert Southwest. If it's a really cool air blob, then our temperatures will hold together nicely to drop by the time that air blob makes it to Austin. But more often than not, here in Texas, we're usually not looking at temperatures cratering with the Pacific cold front because, one, it's not as cold as the Arctic. And two, it's got to move over all those western states before it reaches us. So the air mass is going to modify some as it interacts with the land before it finally gets to us. It's the same reason why if I show you some of the Canadian fronts, and we're getting colder in progression, Canadian cold fronts are the same way. So relative to the Pacific, the Canadian air mass is going to be a little colder, right?
Yeah.
And so those temperatures start off colder. As they modify, that air mass moves all the way down to Texas. It's maybe not quite as cold as what it was when it started in Canada, but it is a boundary that marks the arrival of that colder air mass. And then we'll just take it one step further to finish the thought. The Arctic cold fronts.
Even colder. I
mean, that's North Pole air that comes down in these blobs, this air mass. And the very beginning, the cold front is the leading edge of that air blob. These Arctic cold fronts, I wouldn't say are common here in Central Texas, but we've certainly had some. I would say at least one or two every winter.
Around like January,
yeah, they
February.
can really get us. I mean, you think about the winter storm of 2021 a few years ago,
yes.
The 8-9 days of very cold temperatures. We had an Arctic cold front come through at the very beginning of the week and just cratered our temperatures. And if they're strong enough, these Arctic cold fronts, I mean, they can go all the way out to South Texas and into the Gulf. Now, obviously, they modify some as they interact with the warmer temperatures that are already in place. But if you get a cold air mass that comes in and then maybe a storm system on top of it that's dropping rain.
Snow.
Or snow, yes, and it's got to fall through that colder air that's already in place down here at the surface. You get what we had in 2021. We get what we had in the ice storm of 23. That was a cold front that came in. Temperatures right here at the surface where we live were well below freezing. Then you had a storm system come in from the north, and any bit of rain that we had up top, that cold air froze by the time it got down to us.
Yeah.
And we had one of the worst ice storms in Austin's history. 2021 was interesting because it was the cold front and then it was back-to-back storms. That's why we had so much ice, is it wasn't just one low pressure system that came in underneath that cold front. Above the cold front, it was a few different ones. In fact, if I remember correctly, it was 6 different disturbances that came in after that cold front. So you've already got the cold air here at the ground. when the cold front came through, and now you just have moisture running in up on top of it and just continued to plague us.
For 2 weeks
Yes,
straight.
it was-
I remember that.
Woo, it was a doozy, yeah. So these cold fronts, kind of like the air masses, are named based on where that air originated. So the Arctic cold front typically brings in that continental Arctic air mass. The Pacific, right? Sometimes that would be maritime polar. Canadian cold front would also be maritime polar or continental polar, depending on just how far north it comes in. But those are the different kind of cold fronts that we're looking at here in Texas. Sometimes we'll get what's called a blue norther, and that's a very strong cold front. It's a sharp cold front that comes down from the north, and that's when temperatures crater.
Is that common?
No, but they're pretty spicy. I mean, when they come in, and they'll drag temperatures down immediately in their wake from North Dakota, South Dakota, Nebraska, Kansas, Oklahoma.
Until it gets down.
Temperatures will just nosedive in its wake, and sometimes we can see those too. But those are kind of typically named because it's a very sharp, a very quick drop in temperatures, where sometimes these could be a little bit more gradual. Cold fronts. The leading edge of a front is a little steeper. I think I have that next. We'll come back to the dry line. Cold fronts are a little steeper than warm fronts. So cold air is heavy. It's dense, and so it sits lower. And as it's plowing over land,
through.
It's lifting up anything that's in its path. So this is a good illustration from NOAA that I loved. You can see the cold air coming in with the blue arrow, and it's lifting up the air that's in front of it, which isn't as dense, and that lift can create rising air, storms, showers if there's enough moisture. That's the big if. So a cold front that we can maybe see here in Texas in the springtime certainly does this, right? When we get some of that Gulf warm air, muggy air out in front of the cold front comes plowing in, and that warm, moist air has to rise. It's not going to go into the ground. It's got to go up. And right along the cold front, we can see some really, really powerful storms. Warm fronts aren't quite as sharp. Their slope as they come in along the front aren't quite as steep. They're a little bit more shallow. So it's possible to get some storms and showers up along the leading edge of a warm front, but it's those cold fronts that can really do some damage. Yeah, it's if you ever hear us talk about a squall line, and especially this time of year in the fall, a lot of the times that's associated with the front. It's basically as that front is moving through and it's lifting up that warm, moist air out in front of it, we can see storms line the entire cold front all the way down. Sometimes we say it's like unzipping those storms down the front. Cold front, warm fronts typically come in from the south, because to our south and east is a warm body of water, relatively speaking, the Gulf. Yep. And so warm fronts would push warm, muggy air from the Gulf over Texas, whereas cold fronts typically come down from the north or northwest.
Interesting. Kristen, when you talk about cold fronts, or when we're listening to your forecast and we hear a cold front is coming, is there a way to necessarily know what the temperature of that air that's coming is going to be? Or is it a matter of where is it coming from? What direction is it going?
A little bit of all of what you just said. So oftentimes when I'm looking at a cold front like this weekend, I'm looking, one, where is it coming from? Is it coming from the Pacific, or is it coming from the north? If it's coming from the north, temperatures might get much, much colder. If it's coming from the west, If it's coming from the south and west,
Definitely not.
Yeah, there's not quite as much of the cold air packed in behind it. Oftentimes, if that cold front's already over land, I'll look at what it's doing to temperatures behind it in Utah, Nevada, Arizona, New Mexico, see just how well is that cold air holding together. And then the timing of cold fronts are interesting because cold fronts move faster than warm fronts do. Cold air moves faster than warmer because it's so heavy. It's so
just
dense.
Comes and then we're like, where's the cold front? It never came back.
Exactly. So timing out cold fronts can be difficult, especially when you're talking about moisture out ahead of it with springtime storms or fall time storms. Those can be really tricky. Another thing, before we get to school visits, I wanted to talk about the dry line because this will play into a very similar thing as the cold front. A dry line is basically just the separation from the Gulf warm, icky, sticky air and the dry desert air that comes in from the desert Southwest, New Mexico and Arizona. This is a very, very typical, I mean, this happens all the time, so common, part of the climatology in Texas to see set up. If we have a low pressure system that comes in, jet stream drags a storm system through our neck of the woods, you get some of the cooler air behind that cold front. You've got the warm front that's bringing up that warm, sticky moisture from the Gulf, and the boundary where that dried air meets that moist air.
Where we are.
Exactly. That dry line, the boundary between the moist air and the dry air, can also spark storms because right up against that contrast, you're going to see storms start to go up and over. Warm air or moist air is less dense than dry air. That's why clouds float. So when we have a dry line, the dry air can go underneath, the warm air rises, and that's where you get storms. These dry line thunderstorms are very common in West Texas, in the big country. So think Lubbock, Midland, Abilene,
Northern Texas.
Yeah, absolutely. It's really out towards West Texas, Amarillo, Lubbock, Midland, and Abilene. Those storms blow up, and then they move east into North Texas, into Central Texas, and that's why more often than not, our storm threat comes late. I mean, when we see these storms along the dry line fire up, most instability happens 3, 4, 5 p.m., right? Mm-hmm. So you're talking 3 p.m. to 5 p.m. in Amarillo, Lubbock, and San Angelo. So by this time those storms have developed and then straight trucking east towards us,
we're asleep.
It's 8, 9, 10 o'clock at night in Dallas, in Waco, in Austin.
Yeah.
So those overnight setups are really tricky because the instability comes down. Storms are most explosive in the afternoon. So that happens out towards Lubbock, Midland, and Amarillo. By the time they get to us, the sun has set, they're losing steam, but oftentimes they can be more dangerous because it is nighttime, right? People can't see, people are tuning out, they're going to bed.
Some people are driving.
Exactly. Yeah. So those dry line storms, and this is a very much a springtime thing in Texas, and you'll hear us all the time talk about the dry line setup or the West Texas dry line, West Texas, because that dry line typically sits a little further west of us, but it pulls in some of that dry air from the desert, some of the cooler air coming down from the north, and that warm, sticky air from the Gulf. And those three ingredients, if you've got lift along a cold front or a dry line, you're going to get storms.
Yes, and that's what we see during the springtime.
Absolutely.
A lot.
Yeah.
You touched a little bit on clouds, but what are the different cloud types and how many in all is there?
Yeah, I'll show you. So this is actually something I love to talk about when I do studio tours or school visits. And it's a very watered down version, I would say, because there's so many different types of clouds. I say cloud types, they can vary as to what they look like, what they do, different levels of the atmosphere. When I talk to the kids, I'm like, we've got so many different types of clouds. We have tall clouds, small clouds, thin clouds, fluffy clouds, white clouds, gray clouds, clouds up here, clouds down here. I go through the whole thing. But I like to show this visual because you can see there's the low clouds, middle clouds, and high clouds. High clouds very rarely, if at all, produce precipitation. Like you're never going to get a raindrop or a snowflake out of that cirrus cloud. Those little wispy, feathery light clouds,
yes.
Those are tiny little ice crystals way up high in the atmosphere, up high in the sky. You're not going to get anything when it comes to a raindrop or a snowflake. Now, the exception is those cumulonimbus clouds on the far right. Those are thunderstorm clouds.
And those go all the way from the top all the way to the bottom.
Those cumulonimbus clouds can get tall, like thousands of feet up into the sky tall, but you're not getting raindrops out of the top of the cloud of a cumulonimbus, right? They come out of the bottom. So those high level clouds, no snowflakes, no raindrops. Even the middle level clouds, you're not going to get precipitation out of, but we see these all the time. These altocumulus clouds sometimes look like fish scales. Mm-hmm. They're really pretty around sunrise and sunset because they can stretch out and look fantastic. But those low clouds, those are the ones we watch for raindrops and snowflakes, depending on the temperature within the cloud and down here at the bottom. The cumulonimbus cloud, that's a thunderstorm cloud. Those are the ones you can see them from miles away, super, super tall. Sometimes they have looks like it's got a tail. We call that the anvil of a thunderstorm. But the ones down beneath, the nimbostratus would be rain clouds. Those cumulus clouds I call my, here's a closer look at them. Those are my comp ball clouds. They look like comp balls in the sky.
Those are the ones people draw when they ask you to draw a cloud.
Yeah. What do you see in this cloud? Those are oftentimes those cumulus clouds. I tell the kids most of the time they're friendly. They can be far apart. They can be stuck together. Most of the time, cumulus clouds are friendly. When they get unfriendly is when they start to stack, because a cumulonimbus, a thunderstorm cloud, starts as a cumulus cloud. A cumulus cloud that grows in the vertical is what becomes a cumulonimbus or a thunderstorm cloud. But my cirrus clouds, these ones way up high in the atmosphere, these tiny little wispy, feathery light clouds, those are never going to bring raindrops or snowflakes. So I know when I see those in the sky, I'm not worried. But my stratus clouds, these are the ones that hang low.
Ooh, those are scary.
Yeah, they stretch out in the sky like a blanket. When I tell the kids, I'm like, these are the ones that I watch for raindrops and snowflakes. These, depending on the temperature, can bring us precipitation, part of their water cycle. So that's just kind of
do those change color often compared to like the cumulus or the cumulonimbus?
Like to the white and the gray?
Yeah.
Sometimes the gray is just basically just the visual of the water droplets, right? And so the fact that the stratocumulus or nimbostratus, those are the ones that produce my raindrops more often than not, get that gray bottom look to them. Whereas sometimes I wish I had a recent picture, because I know some of you guys at home have seen this, those cirrus clouds, the little ones that look like feathers high up in the sky. Those are tiny ice crystals. And sometimes if the sunlight refracts and hits it just right, you get a little rainbow within that cirrus cloud, within that cloud, and we call those iridescent clouds. And I know some of y'all have sent in some photos of that. An iridescent cloud is basically just a cirrus cloud where the sunlight is refracting off those tiny little ice crystals that make up those cirrus clouds. And it almost looks like there's a rainbow within the cloud. So that can sometimes happen too.
And how do you measure the cloud coverage, or how?
It's interesting. When you hear me on TV say partly sunny, partly cloudy, and mostly cloudy, that's kind of forecaster perspective. So everybody has a little bit of a different opinion on partly sunny, if you really ask us. I usually use mostly sunny, meaning there's more sun than clouds. Partly sunny would be an equal mix of sun and clouds. Mostly cloudy would be more clouds than sun. And then if we say cloudy or overcast, that means we're completely no sunshine, all clouds. But we have different instruments. I'm gonna blank on the name. I think it's an altimeter, whatever it is, that measures cloud coverage at our weather observation sites. I should know that. I'm gonna have to Google it, because the pride of being a scientist in me is weakened right now, not knowing that. But
when you say like it's gonna be mostly cloudy today, on what region are you like forecasting that for? Is it just Central Austin? Is it all of Central Texas?
It kind of depends. Usually it's for the 15 county viewing area that I'm talking about. So like today, I was going sunny, and I mean sunny from Mason to Fayette.
Sunny.
Yeah, all across the area. But sometimes if I do expect more clouds in a certain area, like eastern counties, because you're closer to the Gulf and you get a little bit more moisture, we can do different things. Like we'll say, okay, partly sunny out towards east of I-35, but sunny in the hill country. This is not letting me. Okay. I'm determined, girl, to find this. But I would say most of the time it's the viewing area that I'm talking about. So tool that measures cloud cover. And as soon as I see it, I'm going to remember, be like, yep. Celiometer.
It's a sky imager.
Yes, that celiometer, which makes sense. Celio being the ceiling, that where the clouds are. Ground-based instrument that's used to measure cloud
Is this what they
cover.
look like?
Yeah,
this?
It's within the it's within the weather observation sites that we have usually at the airport. So I usually have a picture of the weather observation sites. Yeah, here we go. So this is
let me put that up.
That's okay. This is our weather stations that we have at the airports. So within there, you see the anemometer up top. Yep, you've got the wind vane. We've got a thermometer inside there. We've got a tool that measures the precipitation, and the celiometer to measure the cloud coverage.
That is how we or you measure cloud coverage. So whenever anyone hears Kristen or any of our KXAM meteorologists saying it's partly cloudy, it's going to be mostly sunny, this is what they use to measure that.
For sure. So this is actual data. So it won't forecast anything. It's just going to show you what are the conditions right now out at, for us, it's the airport. So Austin Bergstrom, and then we've got another one at Camp Mabry. Just to circle back, what the altimeter gives us the height of the cloud. So celiometer is how many clouds are in the sky above us, and the altimeter shows me how low those clouds are. So those two will obviously work in conjunction. But within this weather station, you're going to get all of that. And if you go to the Weather Service page, you can see all the data. Sometimes it's you can set it to where it's hour by hour, but more often than not, when you go to the Weather Service page and get the data, it's every 3 hours that we can get the precipitation. But yeah, barometer, pressure, temperature, wind direction, wind speed, how many clouds, level of the clouds, all sorts of different things from this weather station.
And previously we talked about how you detect tornadoes or some disturbances. Do those devices also help you see what the clouds, if we have a lot of clouds, what kind of clouds we have?
This specific weather station would only show me what's going on here at the ground. It doesn't do anything really up top other than tell me, what the cloud coverage is. For tornadoes, that's usually radar. Radar is another tool that we have that sends out a beam, a radar beam. Basically, you think of it, I tell the kids it's a laser. It's not actually a laser, but it's easier for them to think about, right? It sends a radar signal out. And then it waits to hear like the echo, the signal bouncing back. And so for a tornado, you're looking specifically at winds. There is a radar setting that allows us to see which way winds are going to and from the radar. So if we see an area over Austin and the radar is seeing winds going this way, and right next to it, the winds are going that way, we know something's happening, right? We don't want those winds going different directions right next to each other. Typically, you would see, let me see if it would work.
But those lasers, they can't detect clouds, right? Or
no,
lasers?
yeah, what they're looking for, radar is looking for
debris.
Precipitation. Yep, debris, if there is some based off a tornado, but a radar will send a signal out, and that signal will bounce off a hailstone or a raindrop or a snowflake, and that's the data that we receive. Let me see if I can show you using these different, we can do a whole separate Kristen's classroom out of that. Is it, okay, yeah, you can see it on, this is what we have. When you see storm winds, we don't have a lot of wind out there, but you see how it's all red over central Texas, meaning the winds are going away from the radar. We have a northeast wind today, so the winds are going from Waco to the south and west, right? So this makes sense that it's green, 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 green up into the radar, and then it's red all the way down because the winds in green are going from Waco to Austin, and then from Austin, those northeast winds are going to continue to blow to the south and west. So this is what a normal day would look like. If we were to have a tornado, you'd see really bright greens, really strong winds next to really bright reds, which would be winds moving away from the radar.
Wow. Well, that is a lot of information.
Yeah, I know. We kind of ran through the meteorological textbook right there. But it's interesting. Like I said, if there was an interest, we can go a little bit more into what do we look at when it comes to the radar. But it all starts with the air masses, right? It starts with
the different types of air masses,
the different
where
types,
they come from.
Let me see if I can get back. I got carried away and I got all jumbled up in my and what I was trying to tell y'all here it is. Different types, where they originate from, what that can mean for our temperatures. If we see a really strong cold front and we know that those temperatures are going to plummet, oftentimes it takes a little while for the temperatures to warm back up again after an Arctic cold front. Whereas with a Pacific cold front, maybe a little dip in our temperatures. Yeah. And that's why we're talking about today, because the cold front that we have coming in on Saturday night, Sunday morning is not an Arctic cold front. This is a Pacific front, so temperatures will come down about 4 to 5 degrees, and that's it. We're still going to be in the 90s.
Still feels good.
Yeah, I'll show you here. Oops, I accidentally hit a button. Our temperature swing isn't going to be super crazy, but we'll take any help we can get. We'll go from 94 to 89, which we love. Temperatures overnight will get a little cooler, but in general, this is not the strongest cold front we've ever seen, to say the least.
But can we expect some stronger ones to come before the year ends?
Usually, yeah. Usually when we get later into fall, that jet stream starts to dig a little deeper. We can get some bigger blasts of cooler air. In fact, later today, Chief Meteorologist Nick Bannon is going to preview not this cold front, but that second cold front on Tuesday. He's going to talk a little bit more about that and how there's a little more hope with that second cold front.
A little stronger.
Yes, exactly.
Well, we're excited for some rain, possible rain in the forecast. This looks like great weekend weather for the Texas game as well as the F1 events happening here.
F1, yes. F1, I think we're good. So Texas plays away this weekend. Saturday, it's a 6 p.m. kickoff, and it's in Kentucky, and I think it's going to get a little stormy there. Ooh. So for my Longhorn fans, if you're going to Lexington on Saturday to watch that game, because it's so late, it's in the evening, rain chances increase after dark, so I would certainly bring that burnt orange rain jacket.
Yeah, or umbrella. Bring what you need.
Yes, bring what you need.
Well, we talked about types of air masses, but I do want to hear a little bit about your school visits.
Oh, yes. Thank you so much for reminding. Okay, school visits. Yes. Let me go back one more. Here we go. This is Pleasant Hill Elementary. This is up in Leander. Had the opportunity to talk with their fourth grade last week about weather. This is their fourth grade staff. And I was so grateful to be able to go up there and speak with not only their third grade, but also got to meet the office staff.
Oh, that's
all
so
important.
fun.
Yesterday, I was at Plain Elementary, also in Leander ISD. Plain Elementary was with their third graders yesterday, and we talked a lot. We kind of focused a lot on tornadoes, and if we live in an apartment upstairs, where do we go? And I said, you got to make friends with the downstairs neighbor, right? I can promise you, if there's a tornado and you need to get to a safe place, that is the Texas way, that more often than not, they're going to let you in. So I was at Plain Elementary. And then I believe, no, was that my last one? Plain Elementary. Do we do this one?
This was all in 1 week?
Yeah, I guess. Because the last time I saw you was Wednesday. So
yes.
I did Pleasant Hill on Thursday. I did Plain yesterday. And then on Friday, I'm going to Dripping Springs Elementary.
Wow.
So the schedule is full and packed, and I love it.
And I'm sure the kids are excited, too.
Yes. And it'll be fun because next week I'll tell you a little bit more about it. But on Friday, I'm speaking with their public speaking class at Dripping Springs Elementary. So it's actually not going to be weather focused, but more on how to be a presenter. And so it's something a little different, something I haven't done before. But I'll circle back with you guys on Wednesday next week about what we did, what they've taught me, what they're doing there at Dripping Springs Elementary when it comes to public speaking, because that is not an easy thing to do.
No.
If you're a kid, grown up, for everybody.
That's a skill I wish I learned in elementary.
Me too. I mean, elementary school. And so that's
awesome.
why I'm excited. I'm going to do some research. I've been poking around the newsroom trying to get some ideas from the other anchors as to, what helps you when you're in front of a group. So we'll see. Look for some details on that experience next week.
Next week on Kristen's Classroom, we'll hear all about it. Any random questions that they asked you this week?
Oh, I don't know. I got nothing random, nothing crazy. It's just always interesting to me to see or to hear what they fixate on, because there's usually something that for whatever reason during the presentation, I hold the questions for the very, very end. And there usually is a theme as to everybody wants to know about this one thing. And I will tell you, yesterday, Plain Elementary was all about the tornadoes. Oh. What do I do in this situation? What if this? What if this? What if this? And we'll just run through the scenarios of what if I'm outside in the middle of nowhere and there's no building to get to? And I ask, well, how did you get to the middle of nowhere? By a car. And I'm like, okay, well, there's your car. We're driving to the nearest building. Yeah. So we usually a lot of my time, especially with the littles, is diffusing those worst case scenario, situations where they're like, well, what if I don't have this? And what if I don't have, what if my dog isn't, that was, I guess, one of the funny questions I got yesterday is a student asked, what if I'm outside and there's a tornado warning and I try and go inside, but my sister locked the door? It's like, and you don't want to downplay the question because
it
these
could
are
possibly
serious concerns,
happen. Yeah.
And so I told the student that, when we talk about tornado safety, we talk about this before the tornado happens. So we want to make sure by the time, if there is a tornado, we know out of habit where to go, what I'm doing, who needs to be there. So we talked to our sister today at dinner time.
Don't lock the door.
Don't lock the door. Make sure and I always tell them, make sure everybody you love, 2 legs or 4 legs, all goes into that tornado shelter when that tornado warning goes off. So sister would know not to lock the door if she didn't see you in that tornado shelter.
That is so funny. I wish I could be there to hear all their questions.
Yeah, it's pretty cute. I mean, even, they'll ask, one of the questions I got, and I forget which one, which classroom it was, if there's a tornado warning, do I need to lock the door? And I was like, I can promise you.
I don't think the tornado's going to knock.
It's not going to matter. It's not going to matter if that door is locked or not. It used to be, I think, back in the day, people thought if you opened your windows, like the pressure difference would save your... I mean, the only thing we care about in a tornado situation is you and your loved ones. Don't worry about the windows. The windows are going to break. They're going to, you can fix a window. I can't fix you if you blow away. So that's kind of where that discussion goes if I get led there by the students.
That is so funny. I always love to hear that.
Yeah, it's cute.
Your article is published on our website, kxan.com, and this one talks about all the types of air masks that we discussed here. Anything different in here you want to share?
I don't think so. We kind of go a little bit more in depth on those different air masks, the different kind of fronts. Oh, I guess we didn't necessarily talk about the occluded or stationary fronts. So you can find more details on there about those 2 special fronts. But
these cool graphics that you showed us.
Yeah, those are all from NOAA. So all from the guys and gals, the scientists there at the Weather Service and the Atmospheric and Oceanic Administration. They put together some really cool visuals that I love to share with the students. So figured it would be a good time to talk about it here.
Yes, and this is available on our website, kxan.com. You can find it on the homepage in case you want to teach your little kiddos about types of air masses or just anything that we talked about today.
Yeah, absolutely.
Well, Kristen, thanks so much for joining me, and we will see you next Wednesday.
See you next week.